So we're going to do function notation and inverse functions again. Instead what we'll do is we'll kind of jump to the end and take a look at something that might be a little trickier to deal with. F of x is 5 plus x, so I'll try to put it all in here. F of x is equal to 5 plus x, yep, and 2x minus 3 over 2x minus 3. Okay, the first step here is to find the inverse of that function. So we've gone through a step like this before. Instead of using f of x, I'm going to substitute y in. It's just because it's one symbol rather than what looks like a couple symbols to manipulate. We simplify the process, and then we can jump back. You can even make a statement like this. Say let f of x equal y. And that way we can tell whoever the reader is of our work that I'm substituting in the symbol y for f of x, and that way it makes it a bit simpler. Is equal to 5 plus, I'm going to put it in red because these are the values that we're actually going to invert for. So this one's going to be trickier because what we're going to end up with is we have two x values, and when we invert the y value, which you'll see in the next step, so these will both become y and this will become an x, so we'll have x is equal to 5 plus y over 2, move down a little, 2y minus 3. We have a bit of a dilemma. We have two sets of y and we want to set it equal to y. So one of the ways we can go about doing this is we can see if there's any way to common factor out. It doesn't quite look like it off the top of your head. So what we're going to try to do is get rid of fractions, put them all on the same line, and then see what we can do from there. So we have this value as a denominator. What we can do is we can multiply both sides of the equation by this denominator. And what that's going to do is on the right side, we're going to get like a form of canceling out or equaling 1. So now on the right side of the equation, we'll have 5 plus y. And on the left side, we'll have 2y minus 3 and then times x. So we'll take a look at this. So the goal is to try to get to combine our y somehow. Now, a problem with if we were to distribute this x, so really this x should be distributed. These will no longer be like terms. It won't be helpful for us in terms of trying to figure this out. So we could make it fractional over x. That is one way to do it. Okay, I'm going to do a bit of swapping here and see if this helps us out. Yeah, I don't see a quick way off the top of my head. Well, unless we can do some factoring. Okay, you know what? We'll distribute and then see if that takes us anywhere that might be factorable. That is another option we could use. So we'll distribute the x and we get 2xy minus 3x is equal to 5 plus y. We'll move everything from the right side over to the left, so we'll end up with is equal to 0. And we'll get 2xy minus 3x minus 5 minus y. So essentially when these came over to the other side, we got the opposite operations when they came over here. We now set it equal to 0. There might be a common factor we can pull out, get the same value. Doesn't look like it off the top. If we pull y out, okay, I'm going to put the two y values together beside pardon me, terms beside each other. We have negative 3x and minus 5. I can technically common factor out y from this term, and we'll be left with 2x minus 1 minus 3x minus 5 is equal to 0. Now, equal to 0 isn't wonderful because if we want to divide something by an entire side of the equation, we'll end up with 0 on the right. It's nice for canceling things, but in our case, not wonderful for isolating y. Oh, actually, this does work out. We've isolated the y, so we put it on the same side. Our next step could actually think of these as this is a set we're going to have to move over, and this is a set we're going to have to move over. And technically, there's kind of like two separate terms here. Because this is multiplication, you can kind of think of this as a coefficient or something we're going to move. So what we'll do is we'll move one step at a time so it's a bit clearer. And we'll keep y highlighted in red because, again, the goal is to keep that, get it by itself. We have 2x minus 1. We're going to move 3 over, or negative 3, and we're going to move negative 5. So when we do that, negative 3 will become 3x, and negative 5 will become positive 5. Now what we can do, since we have y multiplied by these values, is we can divide both sides of the equation by 2x minus 1. And when we do that, on the right side of the equation we get, it's commonly called canceling out, but it creates a value of 1. And what's good here is we get y is equal to 3x plus 5 over 2x minus 1. Remember, way back at the top, we actually substituted y in for f at x. Now, we did the inverting, so this is no longer f at x, but in this case, we're going to say that this is f, the inverse of f at x, is equal to 3x plus 5 over 2x minus 1. Now, in the original question, it actually asks us to find out f at 3 and find the inverse function at negative 3. So we're going to have to put it through that equation too. I don't even remember the original. There it is. 5 plus x, 2x minus 3. I'm going to write it out over here just so we know. 5 plus x, 2x minus 3. So we still have to do these two steps of the equation here. We'll start with the one on the right. Let's see if we can't get it in here. We got f at 3. This is probably a bit easier than what we've done in the last part of this question because we had a lot of rearranging. Here it's just really, why did I say plus 3? Is that supposed to be an x? I just thought forward. I did. Okay, sorry. This should say x. In our next step, we're going to turn it into a 3. We'll say plus 3 divided by, and we get 2 times 3, then minus 3. This is really just your regular bed mass, so we get 8 over 6 minus 3, 8 over 3. We can convert it to some decimal, but that works fine for us. It's a fraction, improper fraction. F at 3 is equal to 8 over 3. Works great. Our f inverse, we need to find negative 3 when we plug it in. So we say negative 3 is equal to 3 times negative 3 plus 5 over 2 times negative 3 minus 1. Okay. From here, again, same idea, simple bed mass. We're going to carry this out. So negative 3 times 3 gives us negative 9 plus 5. On the bottom, we get negative 6 minus 1. On top, when we combine that, we'll get negative 4 over negative 7, which is actually positive 4 over 7. So the inverse, when we plug in negative 3, gives us 4 over 7. A lot of work in this question here. We have to go through quite a few steps to really get to the bottom of everything we were trying to do with our function notation and finding the inverse function.